Hi, my name is Amy and this is my presentation on ghrelin. As you can see by this diagram, ghrelin is a hunger hormone and we'll see what it does in the body. Where does ghrelin come from? From the P/D1 cells in the fundus, which is the upper part of the stomach, which we can quite clearly see there. The site of production, where does it come from? In all species, ghrelin is mainly produced in the stomach in the top part, which we just saw. These cells are distinct endocrine type cells and are found in the muscle layer of the stomach. These cells contain round, compact granules that are filled with ghrelin. So what regulates ghrelin? In 1999, ghrelin was identified as the endogenous ligand of the receptor GHSR and belongs to the G protein coupled receptor family. Ghrelin has both positive and inhibitory regulators. Some of the positives include fasting, i.e. not eating for a long time, along with the hormones estrogen, CCK, glucagon, and also deep sleep. Inhibitory include insulin, glucose, and leptin in the bloodstream, along with somatostatin, which is a growth hormone, inhibitory hormone, released from the anterior pituitary. So over the past 15 to 20 years, ghrelin has emerged as a key player in the regulation of appetite and energy homeostasis. Ghrelin achieves these functions through binding of the ghrelin hormone to the receptor GHSR. This then activates the appetite-regulating neurons and also the peripheral metabolic organs such as the pancreas. As we can see here, this picture demonstrates some of the many bodily organs that ghrelin regulates. We discussed the top one, which was the appetite and energy homeostasis that it does, along with the regulation of other systems, the energy expenditure, glucose metabolism, insulin secretion, and also has effects on the heart, which we don't really discuss in this module, but that is also the case. So now we will look at ghrelin and its connection with other hormonal systems. Ghrelin itself is a multifaceted peptide hormone that acts on the GHSR, which increases intracellular calcium concentration via the IP3 signal transduction pathway to stimulate growth hormone release. Ghrelin also increases blood glucose levels by reducing glucose-stimulated insulin secretion, insulin sensitivity, and inducing glucagon secretion. Also, high levels of ghrelin in humans increase the hormones ACTH, prolactin, and cortisol levels. This diagram here shows ghrelin's effect on hormonal systems. We can see here in the pancreas, insulin is down, glucagon goes up, and in the adipose tissue, insulin sensitivity and glucose uptake go down. In the muscle, insulin sensitivity also means lower glucose uptake. In the bloodstream, the blood glucose goes up, and in the brain, growth hormone goes up, which increases food intake for our appetite. There are a number of diseases that is altered by ghrelin. Any disorder of the GI system that involving infection or inflammation is also correlated with altered ghrelin production and secretion. A couple of them are celiac disease and inflammatory bowel disease. But the particular disease I want to focus on here is anorexia nervosa. Studies since 2001 have really gone into this subject, and they have seen that ghrelin levels were elevated in AM patients and reduced after these patients increased their BMI. This shows a negative correlation between BMI and ghrelin, or low BMI equals an increase in ghrelin. Studies have also shown an increase in ghrelin for the AM patients who binge eat and gorge versus the restrictive type i.e. not eating at all, of AN patients. Some reasons why, this is a direct quote: low levels of hormone growth factor and insulin are likely related to low energy and nutritional status in AN. Since IGF-1s stimulate cell growth, whereby an adequate energy state is necessary, and insulin is responsible for anabolic processes which are suppressed due to the lack of energy. Thank you for listening.